And here's the profit, P of x equals negative 0.004 x to the third minus 0.3 x squared plus 600x minus 800. And they are manufacturing 9. They're asking us to find what is the current weekly profit. Of course, that will be P of 9. P of 9, I plug it in and I determine the profit. How much profit will be lost if production and sales drop to 8? So I will determine in part B, P of 8, and then subtract. So loss will be P of 9 minus P of 8. So now I will put this in the graphing calculator. And I just plug in 8, 9, and then 8. It doesn't matter, the order is not important. So negative 0.004 x cubed minus 0.3 x squared plus 600 x minus 800. Good. So I plug in 9, then I plug in 8. So don't forget to highlight to see the decimal digits. So first one is 4572.78, 457278, and the other one 3978.75. How much will be lost? 4572.78 minus 3978.75. Lazy people using calculators. I just want to finish it. 4572.78. I shouldn't be using a calculator for this, but I will. So the loss will be $594.03. Next question. What is the marginal profit when x is 9? What do I have to do to determine the marginal profit and then when x is 9? What is the marginal profit? Anyone?
P prime.
Yes, thank you very much. P prime of x. So negative 0.012 x squared minus 0.6x plus 600. Now P prime of 9 is the marginal cost at 9 when they manufacture 9 laptops. Okay, so I'm going to share. I'm going to go to the calculator. I'm going to plug in the second row the derivative, negative 0.012 x squared, and then minus 0.6x and plus 600. And I don't have to do anything because it will pop up right here for 9. 593.63. I don't want to. I lost my book again. Okay. Use the answers from part A and C to estimate the profit resulting from the production and sale of 10 laptops weekly. 10. So if you remember that approximation, That's our formula. F of x plus dx is approximately f of x plus f prime of x dx. Our x is 9, but we want to talk about 10, which means dx is 1. F of x is f of 9, which we have, 4, 5, 7, 2. F prime of x is f prime of 9, which we have, 593.63. And dx is 1. So please remember this formula is extremely important. The reference was 9. Yeah, they were throwing at us 8 as well, but that's not what we're trying to do. They're asking us from 9 to 10. So meaning if this is 10, the reference is 9, and the minor change is 1. From 9 to 10, the minor change is 1. So this is f of 9, this is f prime of 9, and this is 1. So now here I can write the equal symbol, and I just copy 4572.78 plus 593.63 times 1. And here is what I have. 4572.78 plus this one, 593.63. So 5166.41. That's it. And this was the profit for 10 units. Okay, where's my list? Moving on to 23 on 341. 23, 341. Did I go back? Yeah, I guess I did go back. Okay, fine. So 23. So 341, number 23. Okay, so we are given f of x. We've looked at these problems. Find the linearization at a equals 2. So remember the formula for the linearization. This is f of 2 plus f prime of 2, x minus 2. Because they're telling us that a is 2 or x is 2 is the same thing. We did this problem together in class. So f of 2 will be e squared. F prime of 2, because f prime is still e to the x. This will be e to the second power. And this will be x minus 2. That's it. So L of x equals e squared plus e squared x minus 2 times e squared. Negative 2e squared with positive e squared. So e squared x minus e squared. That's the linearization. Then they're asking us to find, use the linearization to approximate e to 2.1. Okay, fine. So in part B, L of e to 2.1 will be e squared times e to 2.1 minus e squared. And we'll plug that in the calculator. Then it says find e to 2.1 using a calculator. We'll do that in a moment. So e to 2.1. So see how close these are. So let's do that. So e squared I didn't mean that. I didn't mean that. I meant that. Times e to 2.1, and then minus e squared and e to 2.1 I have to recalculate my numbers here. So they have to be very close. So e squared, and x minus 2. E squared minus, yes, minus e squared. 2e squared, negative 2 minus, yeah, that's correct. So they wanted us to determine, oh, sorry, I see. So this is 2.1, sorry about that. So x, so we have e to 2.1, which means x equals 2.1. Multiply by 2.1. Okay. I went directly to, so let me just adjust that. The second one, nope, I didn't mean that. I meant to redo this. Not that one, this one. 2.1. And clear that. That's it. So 8.12796, and the second one 8.166169. Okay, back to the book. Okay, and then what is the difference between the approximation, the first one, minus the second one? If you go back to the notes, you'll see similar examples. So the difference, and I have 8.12796, and I subtract 8.166169. Negative 0.0382. They have to be very close. If you don't get them to be close, then something is wrong. That's when we say, oops. Okay. Next, 26 on 359. 359. 359. Let's look at 26. Okay, we did many examples last time. Let's do this one as well. And I'm on page 8. Okay, so I have xy minus x plus 2y equals 3, and negative 5 2/3 is the point, and this is 26 on page 359. Good. Okay, so we are asked to differentiate implicitly to find, let's read it again. It says, differentiate implicitly to find dy over dx. Then find the slope of the curve at the given point. Okay. So when we differentiate implicitly, if you remember from last time, y is the function of x. X is the variable, So this is plus 2y. So when I differentiate, this is a product. The first function prime is 1 times the second one, plus the first times the second one prime, which is dy over dx. Then minus 1, that's okay, plus 2y will be plus 2 dy over dx, and this differentiated equals 0. See, two terms have dy over dx, so x plus 2 times dy over dx we have to factor out. I move y to the other side and I move 1. So negative y plus 1. And that's it. dy over dx equals this over this. And now all I have to do is just plug it in. When x equals negative 5 and when y equals 2/3. With negative 5, 5 plus 1 will be 6. Ah! I'm rushing. So this is negative 2/3 plus 1, and the denominator is negative 5 plus 2, which is negative 3. And that's it. Then examples of different derivatives. So I selected 3 questions, 3 derivatives. We already did one like this in a previous problem. Tell me if you would like to work on any of these two. 4 natural log x over x to the 5th, or e to 3x squared plus x times 4x to the 5th plus 1. Which one? Or we don't need to.
Can we do the one with the fraction?
This one, perfect, yes, of course. So we have 4 natural log x divided by x to the 5th. When we differentiate, I keep 4 outside. It's a factor. I differentiate natural log and I get 1 over x times the denominator minus the numerator times the denominator prime over the denominator squared. I'll simplify here. 4 stays outside and I have x to the 4th minus 5x to the 4th natural log x over x to the 10th. I recommend you can keep it as is, but you can factor out x to the 4th and then simplify. So if you factor out x to the 4th, then you get 4x to the 4th, and this is 1 minus 5 natural log x over x to the 10th. And only now you can simplify. And then the simplified form will be 4, 1 minus 5 natural log x over x to the 6th. We can come back to others, but I'd like to look at the last problem on 364. 364. And that is 8. This is what we did last time. In 8 we are given, so this is 8 on 364, and we are asked to, given that y equals 5x minus x squared, find dx over dt when x is 4, and find dy over dt, sorry, when x is 4. Yeah, because I'm copying from different things. Okay, find dx over dt when x equals negative 2, and dy over dt equals 2.5. So remember, dx over dt signifies that x is a function of t. Dy over dt signifies that is also a function of t. So now when we differentiate both sides, here we get dy over dt Here we get 5 dx over dt. Here minus 2x times dx over dt. And they want us to find dx over dt. So I have to factor it out. 5 minus 2x dx over dt equals dy over dt. So finally, I'm solving for this because that's what they want. So dx over dt equals this over this. All I need to do now is just plug in those numbers. They say x equals -2 and dy over dt equals 2.5. So dy over dt equals 2.5, and this is 5 plus 4 is 9. I know I'm close. Yes. The only last thing that I wanted to say, but we already did an example, so this is nothing. I was going to ask you to find the rate of change of this function, but we already did an example, so that was it. Any questions? You have 2 hours. Summarize all your notes. Go through all these problems and everything else and say, oh, when I'm asked to find such and such, I have to do these steps. When I'm asked to find the linearization, I go through these steps. When I'm asked to find the marginal cost or revenue or profit. So this is not the cost, but this is profit, sorry. Because the function was profit. But it's the same thing if it's cost. If I'm asked to find on a closed interval, if I'm asked to find the max, relative absolute max and absolute min, this is what I need to do. If I'm asked to graph, I start with the domain, and so on and so forth. If I'm asked to find the rate of change, all I have to do is find the derivative and plug it in. So I will have all the notes